Okay, Unit 6 test review. So on the first one, we're just deciding if it's possible to be a triangle or not. So C is always your biggest side. So for this is my A and my B. And we want to see that A plus B is bigger than C. So 6 plus 8 is greater than 9. And we know that 6 plus 8 is going to be greater than 9. So it's yes. We could check the other ways. A plus C. Which should also be yes. And then also 9 plus 8 is greater than 6. So all of them work. The most important one is when it's A plus B is greater than C. Pretty much that will tell you every single time if it's yes or no. If you chose the biggest side to be your C. So this is my C, A, B. So 4 plus 10 is greater than 16. Well, 4 plus 10 is 14, which is not greater than 16, so this is no. This is my C, so this is A and B. 2 plus 13 is not greater than 30, because that only gives me 15. So this is also a no. Eight plus 67. Ouch.
It didn't even hurt you.
I know. 75. So that is a yes. So remember, this is your A plus B is greater than C. Technically, if you do all of them, you have B plus C is greater than A. C plus A is greater than B. But the first one is the most important. That will always answer the question. Okay, use number 2. A lot of people were trying to make this one way harder than you needed to. It's just asking what's the possible side lengths. So this is where you're just doing 8 minus 6 and 8 plus 6 from the two sides that you do know. And I know 8 minus 6 is 2. 8 plus 6 is 14. Yeah. So I know that it's between 2 and 14. So remember, you always use the less than and your x is in the middle. Okay, so same concept. 10 minus 6, 10 plus 6, this is 4, this is 16. So it didn't say to use Pythagorean theorem, so we didn't have to worry about the a squared plus b squared and taking it that step further like we did before. We only had to worry about that part. Okay, number 3 says use Pythagorean inequality theorem to determine whether the following triangle side lengths are an acute, obtuse, or right triangle. So this is where, again, C is your biggest side length. So this is C, and this is C. And A and B don't matter. So we have 10 squared plus 24 squared and something 26 squared. We have to figure out which symbol goes there. So 10 squared plus 24 squared and then 26 squared. Well, they both gave me 676. So I know they're equal, therefore it is a right triangle. So again, 16 squared plus 12 squared, 19 squared. So I know that A and B are bigger, so C is smaller. If C squared is smaller, it's acute. So if c squared is bigger, it's obtuse. Okay. Okay, looking at number 4. It says solve the following inequality showing work, and then also interval notation and graphing the number line. So we're going to solve it first. I always like to move my smallest variable first when I have variables on both sides. So minus 6x minus 6x, so I have negative 10 is greater than or equal to 3x minus 4 plus 4 plus 4. And that leaves me with negative 6 is greater than or equal to 3x. Divide by 3, and I get negative 2 is greater than or equal to x. So I know that x is less because I'm reading this backwards. It's eating the negative 2, so negative 2 is bigger, therefore x is smaller. So less goes to the left, and it's equal to, so it gets a square bracket, so everything to the left is my solution. So it goes negative infinity to negative 2 with a square bracket. There's my answer. Okay, here to get rid of a fraction, well, to get rid of a negative, you have to multiply by another negative. And then to get rid of the fraction, you have to multiply by the opposite, the flipped fraction. Okay, so we're going to multiply by negative 5 over 6, so negative 5 over 6 by multiplying. The 5's cancel, the 6 cancels, and the negatives cancel, so we're left with x is greater than or equal to, and on the other side, you can use your calculator, 2 times, and we get negative 5/3. So I know negative 5 over 3, x is greater, it's eating the x, so that's everything to the right, and it's equal to. Oh, freeze, what did I do wrong? I multiplied both sides by a negative, so I should have flipped my symbol, so it's less. Watch those negatives. When you multiply or divide both sides by a negative, you have to flip your symbol. Okay, again, I like to move my smallest variable first, so I'm going to add 2x to both sides. When I have inequalities, the reason I like to move my smallest variable first is it keeps me from dividing by a negative, and then hopefully I won't have to forget to flip my symbol because I'm not dealing with negatives. So I have 10x plus 9 is less than 3, minus 9 minus 9 gives me negative 6. Divide by 10, divide by 10. I get x is less than, and that can give me this ugly decimal. Well, I don't like decimals, but you can simplify it as a fraction. So negative 3 over 5. And x is less, so it goes to the left. It's not equal to, so it gets a parentheses. Okay, on D, we have x divided by 3 is less than or equal to negative 6. The way we get rid of divide by 3 is we multiply by 3, so we're going to multiply both sides by 3. That cancels that 3, and we're left with x is less than or equal to, that gives me negative 18. And we're done. Apparently I really liked the less than sign.
No, it's nothing but that.
You could have greater than on your test. I don't know what I was doing. Okay. We have to distribute anytime we have parentheses. We're not distributing the 6. 6 is not touching my parentheses. I'm just going to bring that down. I'm only distributing the negative 3. Negative 3 times x is negative 3x, and because I'm distributing, the parentheses is going to go away. Negative 3 times negative 1 is positive 3. And I'm not done simplifying because these are like terms. So 6 plus 3 is 9, so I have 9 minus 3x is less than or equal to. This side is simplified, so I'm just going to bring it down. So first things first, I like to move my smallest variable, so I'm going to add 3x to both sides. I get 9 is less than or equal to 6x plus 9, minus 9 minus 9, and they both zero out. So I get 0 is less than or equal to 6x. Do not tell me no solution. Do not tell me infinitely many solutions or all real numbers or whatever, because I still have an x. That's only when your x cancels. Y'all, 0 is a number. So I'm going to divide both sides by 6. And I get 0 is less than or equal to x, or x is greater than or equal to 0. So here 0 greater than goes to the right because it's eating the x, so x is bigger, and it's equal to. Okay, so looking at number 5, solve the following inequalities and show work. We were writing these in interval notation and graphing them as well. So here we have to solve both of them, divide by 2, and I get x is greater than or equal to negative 2. This is an and problem. Add 1, and I get x is less than 3. So I have negative 2, and I have 3. X is greater than or equal to negative 2. And x is less than 3. Because it's an and problem, my solution is where they overlap, and they start overlapping here, and they stop overlapping here. This is not included, not included. So my final answer is this. This time I have an OR problem. I'm going to solve both sides. So here I have to distribute, and I get 2x minus 2 is less than or equal to negative 8. Add 2, 2x is less than or equal to negative 6. Divide by 2, and I get x is less than or equal to negative 3. Here we do minus 5, get negative x is less than or equal to negative 2. I have to divide by negative 1, and since I'm dividing by a negative, I have to flip my symbol. And it becomes positive 2. So this time I have positive 2 and negative 3. That's OR, so x is less than or equal to negative 3. Less than negative 3 goes to the left, equal to gets a square bracket. X is greater than or equal to 2. Looks like this. And it's anywhere I shaded because it's OR, so it's allowed to have that gap. So I have negative infinity to negative 3 with a square bracket. Picks back up at 2 and goes to the right forever with infinity. Okay, C, this is an and problem because it's all together. And what I do to the middle to solve for P, I have to do the two outside pieces. I'm not trying to cancel the 7. I'm not trying to cancel the 11. I'm trying to get the P in the middle by itself. So I'm going to do minus 3. And that gives me 4 is less than or equal to negative 2P is less than 8. Now I have to divide by negative 2. And since I'm dividing by a negative, I have to flip my symbols. That gives me negative 4, and that gives me negative 2. So I know that I have negative 4 and negative 2. Be super careful, negative 4 is smaller, so it should be further to the left. Okay, so P is less because it's eating the negative 2 than negative 2. Negative 2 is bigger than P, so P is less than negative 2. Less goes to the left, and it's equal to. And P is greater than negative 4. Greater goes to the right, and it's equal to, or it's not equal to, so it's a parentheses. My answer is where it overlaps, which starts here and stops here, not here, not here.
Is it right?
It's the error. Okay, D is an and problem. So I'm going to add 3, get 5x is greater than 10. Divide by 5, divide by 5. I get x is greater than 2. Plus 6, 4x is less than negative 4. Divide by 4, divide by 4. I get x is less than negative 1. So I have x is greater than 2, and I have x is less than negative 1. That's an arrow, good lord. And this is an and problem, so it should overlap, but it does not overlap, therefore there is no solution. Oh, that should be x, sorry. So those are not there. Okay, this one we are going to solve both. This is an OR problem. Okay, so I'm going to subtract 7 from both sides. That gives me negative 3c is greater than or equal to negative 6. Divide by negative 3, and since I'm dividing both sides by a negative, I have to flip my symbol. So I get c is less than or equal to 2. That's an ugly 2. Or here I have to solve this side. So minus 2, 5x is greater than or equal to 15. Divide by 5, divide by 5. I get x is greater than or equal to 3. Okay, so we have 2 and we have 3. We have x is less than or equal to 2. We have x is greater than or equal to 3. So that's what this looks like, and this is an OR problem. So this was an AND problem, that's why it wasn't allowed to look like that, but since this is an OR problem, it is allowed. So it's the left forever, which is negative infinity, to 2 with a square bracket, has a gap, picks back up at 3 with a square bracket, and goes to the right forever, which is at positive infinity. Okay, I know I didn't box the number line, but that is part of your answer, so it does have to be there. Okay, so let's look at F. Okay, on F, this is an AND problem because it's all together. So we're going to do minus 7 on all 3 pieces. Remember, your goal here is not to cancel one of the sides, it's to get the middle letter by itself. So you should have 3 pieces at the beginning and 3 pieces at the end. So we have 4x, bring down my symbols. Negative 1 minus 7 is negative 8. 11 minus 7, 7 is 4. Divide all three pieces by 4. That gives me negative 2 is less than x is less than or equal to 1. So my smaller number is negative 2, bigger number is positive 1. And remember, you have to read it inside out. So the mouth is eating the x, therefore x is bigger than negative 2. Bigger goes to the right. It's not equal to, so it gets a parentheses. X is less than 1. 1 is bigger, so x is less than or equal to 1. Less goes to the left. Equal to gets a square bracket. And because it's all together, it's an and problem. And solutions are where they overlap. So it starts overlapping at negative 2 and stops overlapping at 1. This is not a part of my solution, not a part of my solution. G takes me into my absolute values. Absolute values means that once my absolute value is alone, which right here it is alone, I have to separate. So here my absolute value is alone, so I'm going to rewrite 2c minus 5 is less than 9. I rewrite it exact. And then I rewrite it 2c minus 5 is greater than negative 9. And I have to solve both. So plus 5, 2c is less than 14. Divide by 2, c is less than 7. Here plus 5, 2c is greater than negative 4. Divide by 2, c is greater than negative 2. Now this is a less than sign, so this is and, because less than. So I have negative 2, and I have 7, and I have c is less than 7, and I have c is greater than negative 2. So it does overlap. And my solution is negative 2 to 7, both with parentheses. Okay, on H, I have to get my y minus 2, the absolute value of y minus 2 alone first. So I'm going to do minus 3, and I get the absolute value of y minus 2 is less than or equal to 1. And now I can separate. So I have y minus 2 is less than or equal to 1, and y minus 2 is greater than or equal to negative 1. Now before I separated, this is an and problem because it's a less than, so it's an and again. So plus 2, I have y is less than or equal to 3. Plus 2, I have y is greater than or equal to 1. So y is less than or equal to 3. Equal to gets a square bracket. Y is greater than or equal to 1. And it's where it overlaps. So between 1 and 3. Okay, this one is a great OR problem. And my absolute value is alone, so I have 5x minus 4 is greater than or equal to 16. 5x minus 4 is less than or equal to negative 16. Solve both. Plus 4, 5x is greater than or equal to 20. Divide by 5, x is greater than or equal to 4. plus 4 plus 4. 5x is less than or equal to negative 11. Nope, 12. Divide by 5, and that's going to stay a fraction. And that's okay. I don't think it simplifies at all. So it looks like that. This is negative. So I have negative 12 over 5, positive 4. So x is greater than or equal to 4. Greater than goes to the right, equal to gets a square bracket. X is less than or equal to negative 12 over 5. Gets a square bracket. And it's or, so they don't have to overlap. So everywhere I shaded is a solution. So negative infinity to negative 12 over 5. Picks back up at 4 and goes to the right forever with positive infinity. On this one, on J, we have to divide both sides by 6 because it's touching. Okay, divide by 6, divide by 6. I get the absolute value of 2n minus 1 is greater than or equal to positive 1. Now that my absolute value is alone, I separate. So 2n minus 1 is greater than or equal to 1. 2n minus 1 is less than or equal to negative 1. And this is a great OR problem. So plus 1 on both sides. 2n is greater than or equal to 2. Divide by 2, divide by 2. And I get n is greater than or equal to 1. Plus 1, plus 1. 2n is less than or equal to 0. Divide by 2, divide by 2. 0 is a number, y'all. Don't freak out. It just is 0. So I have 0 and 1. N is greater than or equal to 1. N is less than or equal to 0. And so they're equal to, and it looks like this. Okay, last page. We got number 6. Number 6 we like. It gives us the number lines. And we're just writing the interval notation. So this goes to the left forever, which is negative infinity. Stops at 3 with a parentheses. That's what it looks like. This starts at 1 with a square bracket at negative 1, sorry, and goes to the right forever. So that's what it looks like. Here's an OR. It goes to the left forever, which is negative infinity, stops at negative 2 with a square bracket, picks back up at negative 1 and goes to the right forever. Here starts at negative 3 with a square bracket, stops at positive 2 with a parentheses. So that is what those look like. Okay, number 7 gives us solutions in interval notation, and it says to draw it. So negative infinity to positive infinity is just all real numbers, meaning everything. So it's everywhere shaded. Here's at negative 3 with a parentheses, and positive 2 with a square bracket, and everything in the middle is shaded. Here starts at 9 with a square bracket and goes to the right forever. And here's an OR problem. It goes to 6 with a parentheses, picks back up at 11 with a square bracket, and it goes to negative infinity forever and positive infinity forever. So that is what those look like. So 6 and 7 were simple. We like those. Okay, last but not least, we have number 8. These are absolute values, but absolute value equations. We like these because there's no number line, there's no interval notation. But anytime I have an absolute value equals a negative, I need to stop because I know it's no solution. Anytime I have absolute value in an inequality, which I didn't see in my review, I need to stop because it's a special case. It's either no solution or all real numbers. But if it's equal, remember absolute values can only equal a positive number. So this is not true, therefore it's no solution. Okay, so on these, just like with our absolute value, our inequalities, we have to get the absolute value alone before we do anything else. So I'm going to subtract 8, and I get the absolute value of 3x is equal to 12. And now I can separate and solve. So I rewrite it exact without the absolute value bars, and then equal to the opposite. Because I can't flip an equal sign like we do in inequality. This one's super simple. Divide everything by 3. I get x equals positive 4. X equals negative 4. Now, they don't always look like the same number. One's positive, one's negative. This is very rare. So I get negative 4, positive 4. Remember, we write our solution least to greatest in fancy braces. To look at C, we have to get our absolute value alone. We're going to divide both sides by 2 because it's touching. So that means it's multiplying, and the opposite of multiplying is dividing. So I get the absolute value of 3x minus 9 is equal to 6. And now we separate. So I'm going to write it exact. 3x minus 9 equals 6. 3x minus 9 equals negative 6. And we're going to solve. Add 9 to both sides. 15. Get x equals 5. Add 9. Now, I want you to realize that this piece doesn't change. The absolute value piece doesn't change. I've had a lot of people making that turn into a plus or something. Don't do that. Okay, x equals 1. So my solution is 1, 5. Remember, you can check your work. You'll type it into the original, and you hit math right 1. We'll freeze. Let's put the 2 first. Math right 1. So 3, 1 minus 9, and we want this to equal 12, and it did. And my second answer was 5. We want it to equal 12, and it did, so we did it correctly. Last but not least, we have this one. My absolute value is alone, so I'm going to rewrite it exact. X plus 7 equals 2x minus 1, and opposite. So x plus 7 equals negative 2x plus 1. Everything after the equal sign was opposite. So now we solve. Minus x, 7 equals x minus 1, plus 1, plus 1, and that gives me 8 equals x, or x equals 8, either way. Plus 2x, plus 2x. I get 3x plus 7 equals 1, minus 7, 3x equals negative 6. Divide by 3, I get x equals negative 2. So again, least to greatest, and we can check our work. So the way to check your work on these, so math right 1, I have negative 2 plus 7 is 5, and I have 2, I have to plug it into the other side as well. 2 times negative 2 minus 1, which is negative 5. So did that first piece work? No, so that's not a solution. And then we have 8, which 8 will work on both sides. Which we didn't really do an example like this before, but it's fine. So we have 8 plus 7, yeah. And then we have 2 times 8 minus 1. So those both equaled positive 15. All the ones on our notes had absolute value bars on both sides, and that's why it worked. So your only solution here is 8. Because the other one didn't work on both sides. You won't have one like that on your test. So as long as you know how to solve it, you'll be okay.